Welcome to Rges Algebra 2. This is Lesson 12B. We're covering 3.4 and 3.5. Our unit is on algebraic fractions, and we're going to look at how to reduce them and how to add and subtract them. The key to reducing fractions is to, 1, reduce whatever you can at the beginning for each of your fraction. And then identify your common denominator, and then convert each fraction. So I'm going to give you several examples of this. So here's an example taken from the world of arithmetic. We're going to factor out each denominator. This one does not simplify, so that'll just be 5. This will be 3 times 5 to find my least common denominator. It's good to do this systematically because as you do it algebraically, it's going to be harder and harder to just do it in your head. So take everything from the first. We've already taken it, comparing it to the second one. We've already got the 5, so we need the 3, and that will be 15. So they'll both now have a common denominator of 15. Now let's not make that line so long. These are my two fractions. The second one, of course, does not need to be converted at all because it's already 15, so there's no problem there. The first one, to get from 5 to 15 as a denominator, let me change color here. From 5 to 15 means I need to multiply by 3, and so I will multiply the numerator also by 3. 3 times 3 is 9. So I've converted essentially this one to a new equivalent fraction, and this one stays the same. Let's look at several more examples. In this one, it's kind of a truncated example in the sense that I don't need to do all the steps. Neither denominator, as it stands right now, can be simplified. So my least common denominator will be the product of those. So the least common denominator will be a minus 1 times a plus 1 for both fractions. To convert the first fraction, I already have the a minus 1, so I need a multiplier of a plus 1. So in the numerator, take a multiplier of a plus 1. And now for my second fraction, I already have the a plus 1, and I need a multiplier of a minus 1. So in my numerator, take a multiplier of a minus 1. And really, you can leave your answer just like that. Okay, one more example here on this set. Okay, this is a good example of one that takes into account several ideas. First off, factoring this, I would get x squared plus y squared times x squared minus y squared. Now, normally, if I were going to completely factor, I would want to factor this also. But look at my other choices here. I don't have anything with x plus y or x minus y. I only have x squares and y squares, so I'm going to leave that just as it is. So let's come back up to this. This will be my, notice this one matches one of these, so that's good. This one almost matches this. What would I have to do? To get an x squared minus y squared, I would have to convert this one here to negative x squared minus y squared. And now I've got something that matches this. Okay, so that's an important kind of idea that we need to have. Now check that with you. If I distribute, I'm going to get the minus x squared and the plus y squared. So in opposite orders, this is what I have. So that's perfect. Okay, so Now, let's take away that last arrow. All right. So this one's good as it is. This one now is good. And this one has become this. Okay, so what's my least common denominator? Well, it would be everything out of the first one, everything out of the second one. Well, everything out of the first one, I'm sorry. Okay, moving to the second one, I already have that as part of it, so I don't need to add anything else. I already have this as part of it, and I could either put a negative in front of everything, but the more logical thing to do would be to take that negative sign and throw it up to the numerator. Okay, so that's how we're going to treat that. So this becomes our least common denominator. So have I changed anything for the first one? No. So my answer then for the first fraction is just going to be what I'm already looking at, right? I could rewrite it with an expanded denominator or not. In other words, I could rewrite it with this denominator, or I could leave it with the first denominator. It doesn't matter, but I'd be more inclined to take it as this form right here. Now for the second one, I already have, looking at my least common denominator, I already have, let me get some things erased here. I already have the x squared plus y squared, so I need the x squared minus y squared. So take that up to the numerator, and I get bc times x squared minus y squared, all over the common denominator, x squared plus y squared times x squared minus y squared. And then finally for the last one, which I'll have to do on the next line, I already have the x squared minus y squared, so I need x squared plus y squared times the numerator, which already has a negative sign. So negative cd times x squared plus y squared all over the common denominator. So go ahead and do 3.4. I think you'll find it works out pretty well. We'll look at any questions in class and do your word problems, which we'll discuss together as we need to. Now let's talk about, on the next page, we're going to talk about adding and subtracting fractions. Now recall, to add and subtract fractions, what you need is the common denominator. So that 3.4 was prelude to what you need for 3.5. You need to add or subtract, you need a common denominator. Add, subtract fractions. The key is the common denominator. Okay, so what we did in 3.4 must be done for every problem in 3.5, and then you add them. So let's look at several examples here. Okay, so here I've got a fraction, and I'm subtracting another fraction, and I'm subtracting another fraction. These signs are tricky, so you have to be very attentive to them. First off, we're going to do a factoring of this denominator, x plus a times x minus a. Oops, excuse me. X minus a. Notice I almost have that in the second one. I need x minus a, not a minus x. So if I took out a minus 1 in front, I would have x minus a. Convince yourself by factoring back or distributing back, you're going to have minus x, that's the second term, plus a, that's the first term. So those two are equivalent. Deal with this negative sign by combining it with this negative sign. Okay, so this now will become a plus. All right? And so I've dealt with that, and now I've converted this denominator to that denominator. And then I'm going to leave this denominator just as it is. My least common denominator will be the product that we see right here. So we're going to have x plus a times x minus a. And that will be the denominator for all three of them, so I just like to put it down there once and have the numerators. Okay. So I do not need to convert the first numerator because the denominator is exactly what I want it to be. For the second fraction here, there's the first fraction, no conversion needed. Second fraction, I have only part of my denominator. I need a multiplier of x plus a, and I've converted the sign to a plus. So I'll take a plus x, which I certainly could rewrite as x plus a, the denominator that's sitting there already, and I need to multiply it by another x plus a to get the whole denominator. See how that works? For the last one, I have x plus a. I need an x minus a, so I need minus x minus a, which is already there, and an x minus a to add to the denominator. So check that, make sure you understand why I got that. Now I need an expansion here and an expansion here. I need to be careful to distribute my negative sign, and then I'm going to gather like terms. So again, these problems work out pretty long. Let me go ahead and do that and meet you back here. Okay, so I've expanded my numerator. I haven't expanded it all the way because I wanted to show it to you with the signs in front here and here first. And then we're going to go ahead and distribute those signs or just take away the parentheses. So I'll do that step next. So now I've dealt with my signs, distributing them. And then I'm going to put it all over the denominator. Now I'm not finished. I still need to gather like terms. Notice when I used to say paper's cheap? Okay, it's actually more efficient and you get a lot less errors if you go ahead and write down every step. Don't try to do too much in your mind. That's where you're going to make your errors. Okay, this is my answer. Now, I don't know if you're following. I'm not sure if it shows erasing things, but I did make an error there. I miscopied that to a 2a. So I was running in the wrong direction for a little while. Had to back up. 4, 6, 8. AX is all that I'm left with once the canceling in the numerator occurs. So let me go ahead and show you a couple more problems. Okay, a problem like this, notice only the first term has a denominator, so that will be the common denominator. The first term does not, in the numerator, does not need to be adjusted. So we'll bring it down just like that. The second one will need to be multiplied by a 2, and so that'll be plus 10a. A plus 10a is 11a. The minus 1 needs to be remembered, all over 2, and that's as simple as it gets. Okay, so the first ones are not that difficult. Let me go ahead and show you a couple more complicated ones here. Let's pick some other even numbers. Let's go 16. We get b minus c over bc minus a minus c over ac. So my common denominator will be BC plus the times the A, so it'd be ABC. In my first term, I need to multiply by A. In my second term, I need to multiply. I can distribute this negative later. Okay, I'm going to take A minus C multiplied by the B. Normally I would write this with my minus b here rather than the b afterwards. Okay, my next step then will be to distribute that and to distribute that. I'm going to get AB minus AC minus AB plus BC all over ABC. Looking for like terms, These will cancel out, and you'll get BC minus AC over ABC. Factoring, I can factor out a C, and I'll get B minus A all over. Factoring out a C, I guess I should do that in 2 steps. Well, I'll do it down here. Okay, times C all over ABC. And then canceling out my C's, I get B minus A over AB. Okay, looking for one a little more complex than that. Let's do, let's do 22. I will go ahead and factor this, giving me x plus 1 and x plus 3. FOIL back to make sure. X squared plus 1x plus 3x is plus 4x. 1 times 3 is 3. And notice that I have part of that over here in my second term. Okay, so that's good. All right, so converting now to a common denominator of x plus 1 times x plus 3. I do not need to then, because that is what I have here in the first term, right here. I do not need to change this. I could have 2x plus 2. Here, however, in the second one, I need a multiplier of x plus 1, so you're going to have plus from here. 1 in front would be kind of irrelevant here. So I'll write x plus 1. I normally wouldn't expect you to write that, but we'll go ahead and distribute it, just showing you what the thinking is. 2x plus 2 plus x plus 1 all over the common denominator. And now gathering like terms, I have 2x plus x, or 3x, and I have 2 plus 1, or 3. So you're going to expand to gather like terms, and then after you've gathered like terms, you want to factor. Okay, so let's go ahead and put it over the common denominator, and the next step would be to factor that numerator again so I can see if I can cancel. So of course you see that the 3 comes out, and I'm going to get x plus 1 all over x plus 1 times x plus 3. My x plus 1's cancel out, and I'm going to finish with 3 over x plus 3. So I think that's certainly enough to help get you going, and then we will look at any complications you might have on Monday. Have a wonderful day.